Hello, everyone, and welcome to the Excavation Competent Person Training. This is the OSHA Excavation Competent Training, and my name is Josh Barron, certified instructor here at North Country Heavy Equipment School. And today we're going to be covering CFR 1926 Subpart P, which covers excavations, trenches, excavation cave-ins, trench cave-ins, and is going through all those specifics. So I look forward to spending the next couple hours with you. And there's a lot of information that's covered throughout this presentation. So feel free to go through this presentation a couple times just to be able to really get all the information that's covered. And there'll be some downloadable PDFs as well as some other videos on top of this that we'll get into later on. So let's go ahead and dive right in. First of all, why training? Well, regulations are clear that employees must be trained no matter how much experience they have, and that it is the employer who is responsible for overseeing that safety training, ensuring employees have that understanding, knowledge, and skills needed to operate safely. So initial training and refresher training must be documented and filed. So after completing this training, you'll receive a certificate of completion, and that'll be documented and filed on your behalf. At the very least, employers need to show proof of proper and consistent training in the way of training outlines, class lists, training goals, tests, or certificates. These documents should include the name of the person who taught the class or conducted the evaluation. OSHA standards. So once again, we're going to be covering CFR 1926 Subpart P. Now, this part of the Code of Federal Regulations covers everything when it comes to excavations and trenching. Now, excavations, trenching, and cave-ins specifically are the most dangerous when it comes to construction and when it comes to excavating trenches, cave-ins, the most dangerous. So we're going to be covering this in explicit detail here. And you can see as we go throughout here, we're going to be covering scope, application, definitions, specific excavation requirements. Subpart P, Appendix A would be that soil classification. Appendix B, sloping and benching. Appendix C, timber shoring for trenches. Appendix D, aluminum hydraulic shoring for trenches. Appendix E, alternatives to timber shoring. And Appendix F, selection of protective systems. And then we'll get into training, education, as well as general safety and health provisions. Note, there are the main standards concerning trench safety, and employers have the responsibility to train employees. Many states have additional standards on top of OSHA, and it is your responsibility to know all federal, state, local, and company rules that apply to your machine and job site. So that's important to know that what we're going to cover today is the federal regulations, the federal OSHA regulations. Now, a lot of states adopt these regulations, and a lot of states adopt these regulations and also have additional regulations. So just so you know, depending on the state, you could see some additional information depending on those state rules and regulations. All right, so the competent person, who is he or she? It's an individual designated by the employer who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to workers. This person is also authorized to take prompt corrective measures to eliminate them. So tasks of the competent person include classifying soil, inspecting protective systems, designing structural ramps, monitoring water removal equipment, and conducting site inspections. I will tell you, every job in the United States, when it comes to pipeline work, when it comes to trenching, when it comes to excavations, every job has to have a designated competent person on that job site that is, once again, in charge of all these different things. And we'll talk about that more. One of the most important responsibilities of a competent person is to conduct a pre-shift inspection. This inspection will include inspecting the excavating site, utilities, wet conditions, and hazardous atmosphere. Whenever you conduct an inspection, document the results for your employer's records. So once again, at the end of the training, we'll have some downloadable PDFs that you can download on what this inspection should look like, as well as those record-keeping requirements. But just know you got to document it, and you have to document those results, and you got to record it so that your employer, as well as you know that, hey, nope, these were done, this is what I found, and go ahead and take those proactive measures before anything happens. Hazards with excavations. There are several hazards associated with excavation and trench work. These include falls, being hit by machinery or shielding, electrocution, drowning, cave-ins, and asphyxiation due to hazardous atmosphere. So we're going to talk about all these. The big one here is going to be trench excavation, cave-ins, but all these are going to be hazards when it comes to trenching and excavation work. Soil composition. So soil composition is going to be what is the soil made up of. So it's made up of minerals, water, air, and organic material. So solids are going to be the solid particles in soil can consist of rock and other materials such as sand. Sand is the largest, silt in the middle, and clay is the smallest. Other solid particles include organic and inorganic. And then you have gases that are mixed in with the soil, and they are found in the airspace between soil components. So primary gas is atmospheric air, which contains approximately 20% oxygen and other gases such as nitrogen, methane, and carbon dioxide. And then, of course, you have water that and moisture that's going to fill in some of those gaps as well. Soil cohesiveness. So soil cohesiveness is the ability of the solid particles to cling together. Cohesive soil is not crumbly and is plastic when moist. When it is dry, it is very difficult to break up. So the best way I can explain this is think of clay, think of Play-Doh, and how sticky and cohesive it is. It really doesn't break apart, and that's why kids like to play with clay, because they can mold it into all sorts of different things. So the more clay and silts a soil contains, the more cohesive it is, and the stronger the wall, the trench wall will be. Granular soil, such as gravel, has very little clay content and no cohesive strength. So those are kind of the opposites when it comes to cohesive, highly cohesive, and granular. So cohesive, a lot of clay, it's very sticky, it sticks together, it clings together. And granular, is it? Nope, it doesn't stick together, cling together like this pile of 22A or 23B road gravel. It really doesn't stick together a whole lot. A pile of rocks is gonna go in and fall down, as you can see here. It's not gonna stick together like clay is going to, and we'll talk about that more. Cemented soil. So cemented soil is also called hardpan or caliche. It's also known as calcrete and duracrust. So it's a hardened natural cement of calcium carbonate that binds other materials. So it's like a natural cement that forms in the ground. Now, you don't see this really in the northern states, but you do see it in the southwest quite often. So including Texas, Arizona, Nevada, California, New Mexico, and it can be very hard to dig through. So you can see that hard pan right here, and kind of in this picture, you can see that little layer of hard pan right there as well. So this can be a foot beneath the surface, it can be 6 feet beneath the surface, and this can be really difficult to dig into, and it can be, so this cemented soil can be technically silica cemented, it can be iron cemented, it can be lime cemented, or gypsum cemented. And a good example I can give is, you ever seen like a crushed limestone driveway? So they always said that was a poor man's concrete. It's crushed limestone, because when you crush limestone and and you go ahead and compact it with a plate compactor or roller or whatever, and you add a little bit of water to it, when it solidifies, it kind of acts like cement. It's very solid, it's very strong, and it's very difficult to break up when you want to excavate it later on. So the same thing happens to this cemented soil, but this happens naturally in the ground. And once again, those accumulate, and it's almost like, kind of like rock, but it can be very difficult to dig through. Once again, known as hardpan or caliche. Once again, a lot of names for it, but very common down in the southwest. Hardpan can account for poor soil drainage, difficult soil drainage for plant growth, and excavation problems at construction sites. So once again, it can make it difficult to dig into and to dig through. Sometimes what I've seen is people using jackhammers or power hammers to get through it, or ripping through it with like a ripper attachment on an excavator. If you ever heard of tiger teeth on a compact excavator, those are common too, to help rip through that kind of thicker cemented layer. And once again, they're very common in arid and semi-arid regions that really don't get a lot of precipitation sanitation. So once again, places like Texas, Arizona, Nevada, California, New Mexico, all places that you're going to see stuff like this.